Welcome. Today we are tackling something that I know has happened to all of us. It's that moment when you're talking to an AI and it gives you an answer that sounds absolutely 100% positive, but is just completely, utterly wrong. We're going to get to the bottom of exactly why that happens. You know that feeling, right? It's so weird. The AI sounds so sure of itself, so authoritative, but the thing it just told you is pure fiction. It kind of feels like a glitch in the matrix, but believe it or not, there's a really fascinating reason this happens. Okay, so take a look at this. This single image right here holds the entire secret to why AI can be so confidently incorrect. Think of this as our map. We're going to follow it, and by the end, this whole thing is going to make perfect sense. All right, first up, to understand what's going on, we first need to figure out how an AI even thinks about being certain. And to do that, we have to borrow a really cool idea from a field called information theory. Now, the big fancy word for this idea is entropy. But don't let the name scare you off. All you really need to know is that for an AI, entropy is basically its surprise meter. It's how it measures how predictable or how surprising the next word in a sentence is likely to be. So this whole thing really boils down to two sides of the same coin. On one hand, you've got low entropy. That means things are predictable and the AI feels what we would call confident. On the other hand, you've got high entropy. That's where things get unpredictable and the AI is uncertain. So let's tackle these one by one. First up, let's dive into the world of low entropy. You can pretty much think of this as the AI's comfort zone. Its happy place, where everything is super straightforward and the answers are crystal clear. Okay. Let's go back to our map here. We're zooming right in on the left side. This is the perfect picture of what a low entropy, super low uncertainty situation looks like for an AI. And the example question couldn't be simpler, right? What is 1 plus 1? Now think about it. Across the trillions of web pages, books, and articles the AI was trained on, there is one and only one overwhelmingly dominant answer. There's just no room for debate here. So if you could see the AI's thought process as a graph, this is what it would look like. It's not really thinking, of course, it's just predicting the next thing to say. And you can see that the probability for the answer, 2, is so incredibly high that it just towers over everything else. All the other possibilities are basically at 0. And this is why the loaded die analogy is just so perfect. The AI's training data has basically loaded the die, weighting it so heavily that it is almost guaranteed to land on the number 2 every single time. The outcome is so certain, so unsurprising, that the AI spits it out with what we hear as maximum confidence. Okay, so we've seen the loaded die. Now, let's flip the script and look at the total opposite, high entropy. This is where things get a little messy, a little creative, and way, way less predictable. So now we're shifting our focus over to the right side of our map, and you can see the difference immediately, can't you? There's no single giant spike. Instead, you've got this spread of different options. We've officially gone from a loaded die to a fair one. And look at the question here, dinner ideas? I mean, there's no single correct answer for that, right? What you want for dinner is just as valid as what I want for dinner. This is the absolute definition of a high entropy problem. So when the AI gets a question like this, it sees a whole buffet of statistically plausible answers. Unlike 1 plus 1, no single option is the clear winner. The probability is just spread out across all these different tasty choices. And that brings us right back to the fair die analogy. You roll it, and any side it lands on is a totally valid outcome. The AI might randomly pick pizza to give you, but in the back of its mind, it knows that pasta or sushi were almost equally good bets. That is what uncertainty means to an AI, just a wide spread of viable options. Okay. So we've seen how AIs can be confident and how they can be uncertain. But now we get to the absolute heart of this whole thing, the crucial mistake that we all make when we talk to them. This is what you might call the confidence trap. And here it is. This is the single most important thing to take away from our little explainer today. For an AI, confidence does not equal accuracy. Let me say that again because it's so important. An AI's confidence is just a measure of how predictable an answer is based on its data. It has literally nothing to do with whether that answer is actually true in the real world. So that brings us right back to the beginning. If the loaded die means the AI is confident, how in the world can that confidence be wrong? How can such a predictable answer be a complete lie? Well, the answer is actually really simple. The die was loaded with bad information from the start. Just imagine an AI that was trained on millions of old websites and blog posts.
that all incorrectly state that you can see the Great Wall of China from space. The AI will see that so-called fact so many times that it becomes a low entropy, high probability answer. The die is now loaded to give you that wrong answer, and it will say it with the exact same level of confidence as it says 1 + 1 = 2.
So, I want to leave you with this one final thought. The next time you use an AI and it gives you an answer that just feels incredibly certain and correct, just pause for a second. Ask yourself, am I being convinced by the actual facts, or am I just being swayed by the AI's confident tone? Because knowing the difference, that's the key to using these amazing, powerful tools wisely.